Hey guys, welcome to our 2.1 video, and in this video we're going to be talking primarily about accuracy and precision, and then we'll also be talking about percent error. So accuracy and precision are two words that oftentimes students think are talking about the same thing, but these terms are actually very different in the way we use them in chemistry. So we use two words to describe how good measurements are in the lab. The first term is accuracy, and this one usually students their outside knowledge of this term is the same as the inside knowledge of our classroom, which is that accuracy is how close the measurement is to its actual values. For example, if I go to the lab and I measure the boiling point of water to be 101 degrees, and then I check from my teacher and I realize the boiling point of water is actually 100 degrees, then I know that I'm fairly accurate, right? I'm within a very small margin of error. However, if I measured the boiling point to be 150 degrees, you can see that I'm no longer accurate. So how close you are to the real measurement is what accuracy is. Now precision is different. Precision is not how close we are to an actual value. It's actually how often your measurement can be repeated and get the same value. For example, if I went back and I measured the boiling point of water 3 times, and all 3 times I measured it to be 101 degrees Celsius. That's very precise because I'm repeating the same measurement over and over again. Let me show you some visuals to help you understand the difference between accuracy and precision. So if I use a dartboard analogy and I throw 3 darts at the board and all 3 of these darts hit the same spot on the board, that I see that my measurements are being repeated at the same value. So all of these measurements here are repeated. So it's very precise, but it's not accurate, right? These measurements are not near the target. So this is poor accuracy because I'm not near the actual value, which would be the red dot in the center. But it's good precision, meaning I'm very, very good at repeating the same value over and over again. For example, I played basketball 1 time. Horrible idea. But I could always throw the basketball at the same point on the backboard. It never went in, mind you, but I hit that point in the backboard so well all the time. It used to be called Allie's spot on the backboard because I would always hit that same spot. I was incredibly precise. If you needed a precise basketball player, I was your gal. But if you needed an accurate basketball player, you should have someone else. And that's pretty much the rule of my life for like any sport ever. Okay, here's another diagram. I'm showing 3 darts. None of them are hitting the spot, so obviously they're not accurate, but they're all also all over the place, right? So that's like the worst kind of player to get because it's like unpredictably bad. They never hit the right spot, but they're going to hit the wrong spot a bunch of different places. So it's not accurate, okay, because we're not hitting the correct spot, and it's also not precise because our measurements are not repeated. We're not repeating that same hit over and over again. And here we go with our final diagram. We see all 3 darts are in the accurate spot. So it's accurate, good accuracy. It's also good precision because we can repeat the same measurement. Okay, so accuracy, interestingly enough, can be true of just one measurement or the average of several measurements. For example, if I measured the boiling point of water once, I could still tell whether that one measurement was accurate. If I did it 3 or 4 times and I wanted to see if they were accurate, I would need to average them and then look at my average and say, okay, is my average accurate? Precision is different. Precision, to figure out if something's precise or not, you can't just look at one data point because precision is all about repetition. Can I repeat this measurement and get the same measurement over and over again? So you have to have several measurements before you can say anything about it. So here's a golf analogy. Isn't that a fun little sound? And the golf ball's like going over the green and it's not hitting the spot, but they're close, so we see they're precise, but they're not accurate. It's not accurate, but it is precise. Here are 3 more golf balls. They're very precise because they're in the same area, and they're accurate because they're near the hole. Here's our last one. Did you see the golf ball? It just drowned in the water. That was funny. So these 3 are nowhere near the accurate target, so they're not accurate. And they're also nowhere near each other, so they're not precise. Sorry, let me show you this one. This one, we just have one golf ball, and it made it into the hole. Yay! So it's accurate, Well, we don't know if it's precise because we only see one measurement. It'd be precise if he was able to repeat the same hole-in-one over and over again. So just to recap, accuracy is how close the measurement is to an accepted value. So accuracy, a short word for accuracy, is correct. If it's correct, then it's accurate. Precise is how close these measurements are to each other. So something's precise, it's very consistent. And those two words kind of sound similar, so hopefully they'll be easy to remember, but that's the best definition for precise. If you just want a one-word definition, precise is consistent. It's reproducible. That's super important in the lab because if you get something right once, but you don't get it right any other time in the lab as far as measuring, then that could have been a fluke, right? That could have been an accident. So we always do multiple trials and multiple measurements every lab to make sure our data are precise, okay? So 3 students measured the width of the classroom, and we have these 3 measurements, 10.2, 10.3, and 10.4. Were they precise? Were they accurate? Well, in order for us to answer those questions, we would need to know how long the classroom is, right? Well, let's say I tell you that the classroom is 10.3 meters across. So if I said, okay, it's 10.3 meters across, that's the accurate point, then I would need to always average together my numbers. Okay, so average all data, and then I'm going to see how close that is to my to the accepted value. So I would take 10.2, 10.3, 10.4, I'd average them together, and then I'd see how close that was to my accurate value. And I'll show you a little bit how you can tell whether something's accurate or not when we talk about percent error. Were they precise? I look and I say, okay, are these numbers close to each other, relatively close to each other? And I can say yes, they are, right? They're only differing between 0.2 meters, so that's a pretty small range. And so we say yes, they're precise. Range is a really good term to know and put on your notes. Range just talks, it's really about precision. It's about how far apart your measurements are. So I would be taking my largest measurement, 10.4, my smallest measurement, 10.2, and when I subtract them, I get my range. So 10.4 minus 10.2, and I get a 0.2 range. So that's one way you can actually measure your precision, is subtract your numbers and see how close they are to each other. Okay, now we're actually going to apply that to a problem. So this is a problem that you could see on a test or a quiz. It shows 4 different students used 4 different thermometers. So here's student 1 with thermometer 1, here's student 2, 3, and 4, okay? And they repeated their trial 4 times, all right? So thermometer 1, or student 1, tested the water 4 different times right here. In order to determine whether something is accurate, you always have to take the average. That's really, really important. So they took the average of thermometer 1, and this was their average, which was 100.0. Student 2, or thermometer 2, had an average of 100.1. Student 3 had an average of 98.5, and student 4 had an average of 97.0. So how close is this average to the actual value? If I told you the actual value was 100.0, which student or which thermometer would you say would be the most accurate? Well, obviously that would be thermometer 1, right? That would be the second question. I guess I skipped the first one. Which thermometer is the most accurate? I would say thermometer number 1, because the average is closest to the actual value. Now, what single value is the most accurate? It looks to me like this one right here, the third value inside thermometer 1 was the closest. So I would put 100.0. Which thermometer was the least accurate? So which one's furthest away from this actual value? Well, that should be thermometer 4, right? Thermometer 4 is the furthest away from the actual value, so it's the least accurate. And then it says, which student did the best job measuring the boiling point of water? Well, it's tempting to say thermometer number 1, right? Because they got the actual value right. But part of doing a good job measuring is not just getting the accurate value, but getting precise data. So what I look here is I've already pre-calculated the range for all. The range is just subtracting our highest measurement from our lowest measurement. And when we look at these ranges, we can see that the range for thermometer 1, it has a 0.2 range, and that's the smallest one. 2 has a 4.8 range, number 3 has a 0.4, so it's close. And thermometer number 5 was the least accurate. It was also the least precise, so that was the worst set of data right there. But the best set of data would be thermometer number 1. Okay, so percent error is a way for us to really measure how off we are from the actual value. So it helps us determine how accurate and how inaccurate our results were. So this is the formula for percent error. Make sure you write that down on your notes. We take the actual value, okay, and usually you get that from either your lab document or from me, your teacher, minus your experimental value, so what you actually measured in the lab. You divide that by the actual value, and let me put these in parentheses, okay, and then after you do that, you'll multiply by 100. Anytime you want to get a percent, you always multiply by 100. You multiply your decimal number by 100. So let's take this formula and let's apply it. Okay, so here's a group of students, and they were determining density, and these are the 3 measurements they obtained: 1.34, 1.32, and 1.36. Okay, the actual value is supposed to be not 1.34. I'm sorry. The actual value is supposed to be 1.35 grams per centimeters cubed. So that's the actual value. What's the percent error? Well, in order to find percent error, we take actual minus our experimental divided by actual, and then we multiply all of that by 100. So we have our actual value, right? But right here we have our actual value. That's supposed to be a check mark. We have our actual value there, but we need our experimental value now. So how do we get that? Well, it looks to me like we have 3 experimental values, which is true. Remember when I said when you're trying to find accuracy, you have to average. So I want to average all of these together. So I'm going to add 1.34 plus 1.32 plus 1.36. I'm going to divide them all by 3, okay, and then I get 1.34. So that's going to be my experimental value that I use here. So let's write this out. We have 1.35 as our actual, minus 1.34, which is the average, our experimental average, divided by 1.35 again, because that's our actual, and I'll put this in parentheses, and I'm going to multiply it by 100. Okay, and then I end up with, multiplying this by 100, I end up with 0.74%. Okay, so that's my percent error. I have a less than 1% error. So that's really, really great. Anything less than 5% error is great. That's what we shoot for. So if you're less than 5% off, then we say that you're accurate. If you're more than 5% off, we say you're inaccurate. That's something you're going to want to write down on your notes. Okay, then it says how precise were the students' measurements. If it's asking how precise, it means it wants the range. Remember, range is how far away the measurements are from each other. So our range here would be 1.36, because that was the farthest measurement, minus 1.32, which is our smallest measurement, and our range is 0.04. That's a very small range, so we would say it's very precise, and we would also say it's very accurate. And that's it for our 2.1 video. Y'all have a great day.